Hello everyone, and welcome back for this second part of this CFD tutorial on a study of wind profile on a house. In the first part, we made the geometry of the fluid in the vicinity of the house. Now, if we want to model properly the wind profile, we are going to have to create a bigger rectangle in order to really see the wind evolving into the domain. Now, we need to connect this bigger rectangle to the structure we already made. We first use the measurement tool to check that we probably put this rectangle in the center along one direction and a little bit closer to the edge along the X direction. And now, exactly as we did for the smaller rectangle, we are going to project all of the faces of the smaller rectangle to the bigger rectangle. We'll do the same on all of the four faces. And exactly as we did with the smaller rectangle, we are going to make an extrusion by selecting all of the relevant faces of each side of the rectangle and making an extrusion with the appropriate length that we measured before. Once this is done, we can do a partition of everything: the smaller rectangle, the bigger rectangle, and the extrusions. Don't forget to use the remove subshape again to remove the inside of the house that we are not interested in. We still need to project the roof sides, because the extrusions are cut with the roof height, so you need to also propagate this cut along the other directions. So again, this can be done with some extrusions. We are now going to create some groups. The surfacing groups are going to be directly used in Code Saturn for the simulation. So we are creating the symmetries that are all of the sides of the bigger rectangle: the inlet, the outlet, the sky, the bottom, and finally, we need also to create a group of all of the surface elements of the structure. Since we are using Shaper, we can use the history option to go back when we have only the structure and select easily all of the faces of the structure. Then we create a group and we can right-click on the group we created on the structure and use the option Move to the end. Now the structure exists as a group on the final geometry, as you can see. Now that we have made the group, we can start meshing. As a 3D algorithm, we are going to apply an hexahedral algorithm. As a 2D algorithm, we are going to use a quadrangle mapping and create a quadrangle parameter with quadrangle preferences. This way, on the 2D surface, the mesh is going to be mostly made of rectangle. Finally, create a 1D algorithm with a wire discretization and a number of segment hypothesis of 3. This way, you can sketch a very rough mesh with not a lot of elements just to see if and where the hexahedral algorithm is failing. Here we didn't have any issues, so we can look at the final form of the mesh, and you can see that as we imposed 3 elements on each vertices, the size of the elements is not the same. In areas of the mesh where it's not necessary to have finer elements because we don't expect any strong pressure or velocity gradient. To solve this issue, we'll go back in Shaper and we are going to create some 1D vertices group. This time we are going to create a small vertices group that's going to contain all of the smaller vertices elements on which we are going to impose a wire discretization of only 1. In order to make this group, we can use the filters option. Now if you do show only, you can see that it's only going to pick the vertices that are smaller than 2 meters. Likewise, you can make a medium to small vertices and use a filter that is going to be edge size is between and then select between 2 and 5. Now if you do show only, you see you have a little bit bigger types of vertices. You can make the medium vertices that is between 5 and 10. And finally, we can go back to mesh, and this time we are going to create submeshes. Each time we are going to select as the geometry of the submesh the groups we just created, and for instance for the small elements we are going to impose a wire discretization algorithm with a number of segment hypothesis of 1. The interest of submeshes is that if you set a number of vertices that is too high for the global mesh, you can impose locally a lower number of vertices. Now for the medium to small element, we are going to impose 5 elements. For the medium elements, 10 elements. And you can see that if you clear and compute the mesh, it is indeed creating the number of elements that you asked. Now we are going to change the global mesh number of segments and set it to 60. If you regenerate the full mesh, you can see that all of the elements are about the same size. Thank you for watching this video. In the final video, we are going to show you how we can set up a CFD study with this mesh and how to use the atmospheric module of CodeSaturn. Goodbye!